Hello and welcome to my Python programming video for complete beginners. If you are just starting out with programming, you are in the right place. My name is Devraj Agarwal and I will be guiding you through this journey. I am an experienced software professional with 25 years of expertise in building and managing applications across consulting, finance and various other industries. In this series, I will be covering Karel the Robot over multiple videos. We will start with the basics and gradually move on to more advanced and challenging concepts, giving you a solid foundation in programming through Karel's world. By the end of these videos, you will have all the skills you need to master Karel and understand key programming concepts. If you are looking to dive deeper and learn the complete fundamentals of Python, I recommend checking out my Python's beginners course on Udemy. This course offers easy to follow lessons along with quizzes, exercises and solutions to help reinforce your learning. The course link is shown here and in the video description below. So what is Karel the Robot? In the 1970s, a Stanford PhD student named Rich Pattis created a robot named Karel to make it easier for beginners to learn programming without getting lost in the details of the language. Karel was an instant success. It became a popular tool for teaching programming to beginners, not just at Stanford, but all around the world. In this video, you will get hands-on experience by programming Karel to complete tasks such as moving around, picking up objects, and solving puzzles. This will help you understand the core concepts of programming in a fun and engaging way. There is a nice introduction to Karel that is available from Stanford. You can find it at the link shown on the screen. I will advise you to review the information at this site to make yourself familiar with Karel. Karel lives in a world which is made up of a grid with 4 directions: north, south, east and west. There are rows and columns in this world. The place where the rows and columns meet, we call them corners. When the program starts, Karel will be on the bottom left corner facing east. Karel can move in this world one step at a time. There are walls in the world. Karel can't walk through the walls. There are objects called beepers. Karel has an infinite supply of these beepers. It can put down beepers in the world or pick them up. Karel knows only 4 basic commands: move, turn left, put beeper and pick beeper. There are some additional commands that you can find at the link shown here. Well, this may sound overly simplistic, but you can solve quite impressive challenges using these commands. For those with prior programming experience, please note that you cannot create variables using Karel. The objective is to keep the coding process very simple and teach you the fundamentals of programming without getting into the nuances of the programming language. Before we try out these commands, let's first set up our programming environment. We will be using PyCharm Community Edition, which is available free of cost. Go to the link shown here and click on the Windows link to download PyCharm Community Edition software for Windows. If you are using Linux or Mac, please use the corresponding link. Next, go to your download folder and run the installer. I have already installed it on my machine, so I am going to open it now. Let's open PyCharm and now create a new project in it. We can call it something like Karel project. Keep the locations to default and click on create. So now we have a Karel project. So before we start writing our program, we need to install a package called Stanford Karel. So on the left hand side you see the menus. You click on Python packages and in the search box type Stanford Karel and it shows up here and you just click on install. Select the first item on the top. So it's downloading. So Stanford Karel package is installed. Next, create a source folder in the root of the application. It is better to organize your code in different folders so that it is easier to navigate and maintain files. So right click here, we select new directory and call it source. Press enter. So we have a source folder here now. We are now ready to create our first program. We need to first create a Python source file. We right click on source folder, select new and a Python file. Now you can give any name that you want. Let's call it my first program. You don't need to add any extension. When you hit enter, PyCharm will automatically add .py, which is the extension for Python file here. First, we need to import required libraries or packages. Okay, so for Karel, we write from Stanford Karel import star. There are different ways to import the required libraries. To learn all those ways, you can and how to import packages, you can refer to the course I had mentioned earlier. Next, we create a function called main, def main, open and close parenthesis, put a colon, and then hit enter. Now let's talk about functions before we start writing code here. So how do we create functions? A function in programming is a sequence of commands that can perform some actions. A function is defined using the def keyword followed by the name of the function and then open and close parenthesis, and then you put a colon. So here greet is the name of the function, the colon marks the beginning of the function body. The comment provides the brief description of the function's purpose, and the print hello world is the body of the function. In Python, you need to indent the body of a function. PyCharm automatically indents your code. Otherwise, you will have to indent it yourself. Let's come back to the main function. So here we have the def keyword. The name of the function is main, and then open and close parenthesis with a colon. When you hit enter, code is automatically indented. So you can write your commands here. We will write a single command move to tell Karel to move one step. To end the function code block, we unindent the code. Next, we use the if statement to run the program and load the Karel world. Please ignore why we write it this way. You can refer to my Python course if you are interested in knowing the details. There are several worlds which are pre-created and are available to us. Here we are using a world of size 6 by 5. We now have our first Python program in which we are asking Karel to move one step. Click on the green icon on the top menu to run the program. As you can see, the world with 6 columns and 5 rows is loaded. The intersection of a row and a column is called a corner. Karel can only be positioned on corners. Karel is in the leftmost corner facing east. To run the main function, click on the run program. Karel moves one step to the next corner. The button label now changes to reset world. If you click on this, it will move Karel back to its original position. Ignore the load world button at this time. The slider below this goes from slow to fast. To increase the speed of your code, you can slide the controls towards fast. Now try to move Karel all the way to the rightmost corner. Karel needs to cover 5 corners. So let's go back to the main function and add 4 more move commands. Now run the program. Karel moves to the rightmost corner. We can increase the speed and try again. Now that was fast. If you have a long running program, it will help you to speed up and see the results quickly. Or you can slow down and debug your code to see where the program fails. Next, we are going to add one more move command. This will force Karel to move while it is at the rightmost corner. Let's see what happens. So reset the world and run the program again. Well, the program throws an error. This tells us that we should be careful and not try to give commands which Karel is not supposed to execute. If you see in the console, you can see that Karel crashed while on Avenue 6 and Street 1. So our rows in Karel's world is called street and the columns are called avenues. Invalid command causes Karel to move, but its front was blocked. Now we will place a beeper after making 2 moves. So let's first remove the wrong move command, and after 2 moves, add the command put beeper. Reset the world and run the program again. A beeper is now placed in the 3rd corner. Next, we will replace the put beeper command with pick beeper command. Reset world and run the program again. We got another error. Why did we get the error? Since there was not any beeper, Karel is not supposed to pick a beeper. If you go to the error console, you see that Karel attempted to pick up a beeper, but there were none on the current corner. Karel has infinite supply of beepers. It can put as many as it likes, but can pick only if a beeper exists on a corner. We have a task which is called put beeper in southeast corner. So it's on the east and the bottom is south, so we call that southeast corner. So the starting state, you don't have anything on the screen, and in the ending state is you have one beeper in the southmost corner, and then Karel has to come back to home, which is the first corner, and then face east. Okay, so goal is to put a beeper in the southeast corner and return to initial position. We come back to PyCharm. I have created a new Python file called beeper1se solution and copied the code from the previous program. Now we can edit it to write a program for the new task. There are multiple ways to add comments. To comment single line code, you can add a hash key in the front. In PyCharm, use control key with /, and to uncomment, use the same key again. To add multi-line comments, use 3 single or double quotes. Now first we write the goal of this task. The goal of the task is to place a beeper in the southeast corner of the world and return home. Now Karel should be facing east at the end. Before writing our code, let's break it down into smaller subtasks. So the first task is to move to the other corner, then put down a beeper. Third step would be to turn around to face west. Fourth step would be to move to the other corner. And finally, the last step would be to turn around to face east. So we took our goal and broken down into smaller subtasks. Let's move these 5 tasks as single line comment, which will make it easier to write our code. Now first step is move to the other corner. We already did that in the previous program. So we take this code, put it here, and remove this pick beeper. So we have the 5 move commands which will move Karel from the first corner to the last corner. Let's run it first and see if the code is working as expected. It is always a best practice to incrementally code and test. Run the program. Karel moved to the other corner as expected. Now let me rearrange the screen first. So now as you can see, on the left we have our program, and on the right top corner is our program running, and in the bottom right you have the end state, which is the beeper at the end and the Karel facing east. So far we have completed task 1 to move to the other corner. The next task is to put down a beeper, which should be put beeper. Okay, now reset the world, run program again. So good so far. Now how can we turn around? Karel only knows to turn left. If we turn left twice, it will be equivalent to turning around. Let's try. Let's reset, run again. Working so far. Now we move Karel to the other corner and test. We know the commands to move to the other corner are to use move 5 times, reset, run program. Okay, now the 5th step, sorry, I forgot to copy it from here. is to turn around to face east. We know to turn around, we give the turn left command twice. Let's reset and run it again. Nice. So we completed the task successfully. Our end state is matching what is expected as given in the bottom right corner. There are a few lessons that we have learned here. First, we decompose the bigger task into smaller steps. The process of breaking a program down into smaller pieces is called decomposition. It is a powerful concept in programming. Second, we did incremental programming by coding small tasks and testing to ensure that the program worked before moving on to other tasks. This makes coding easier and less buggy. Though the program worked as planned, we repeated the codes multiple times. Twice we moved to the other corners and twice we turned around. Repeating code is a bad practice. If you encounter any bug, you will have to fix it everywhere that the code is being used. Also, repeating code makes the code base bigger and less manageable. So how can we eliminate repetition? By writing functions. Let's create a function, move to the other corner. Now we know the commands are this, move 5 times. We put our command. Now let's copy this function and replace the code here. We have to use parentheses to call the function. We know we are using the move to other corner here too, so we again replace it. We reset the world and run the program again. It's working. You can make it faster. Now let's create another function called turnaround. We are using turnaround in two different places, so it will be helpful. Now replace the code with the function. Let's reset the world, run the program again. Perfect. So excellent work. So the program is now cleaner and shorter. So we have learned the concept of decomposition, functions, and writing code incrementally. In this task, we are given a world state having some beepers which Karel has to move to a target location. The program will launch with the start state shown here. You have to write a program to command Karel to move 3 of the beepers to achieve the end state. For this task, I have created a Python file, move beepers to target solution, added the initial code, and added the initial code. We are importing the library, writing the main function, and we have the turnaround function from the previous code. Here we are loading a different world called move beepers to target start. Let's run the program. So the start state is loaded where we have 5 beepers on corner 2. If you need to check the end state, you can click on load world and go to move beepers to target end, and you will see the end state. Now the question is, where can you find these states? These don't come with the Stanford Karel library. I've created it manually for this video lesson. All solutions along with required states are available on my GitHub site at this URL in Learn Python with Karel repository. In the GitHub repository, you will see 2 folders, source and worlds. The solution files are in the source folder and the states are in the worlds folder. You can download the entire repository as a zip file or download only the required files individually. Here I will download as a zip file. Now we go to the worlds folder. Here you see all the states. For this exercise, I will first delete the current state file from Stanford Karel library. We go into PyCharm in external libraries, site packages, Stanford Karel, and you see the worlds folder here. Go here, and this move beepers to target start I'll simply delete it. Okay, so I don't have it here. So let me run this program and see what happens. Okay, so I get an error. So it doesn't find the world, and it throws an error. So let's go back to the downloaded file. Control C to copy, come back here, come into this folder, right click, say paste, say OK. Okay. Now if I run the program, it will load the state. So similarly, depending upon the problem, or you can just take all the worlds and just copy and paste them into the Stanford Karel library, and then you will be good to go. Let's write our program to achieve the end state. In the main function, we first have to add the comments. I have added the comments from our goal, which is to go to the pile of beepers, pick up 3 beepers, then go to the target location as shown in the end state, put 3 beepers, and then return home. The first thing that we have to do is to break this task into smaller steps, which is called decomposition. So to decompose this task into smaller steps, we have go to beepers, then pick 3 beepers, go to target, put beepers, and then return home. Now you see pass here, which is just to tell Python interpreter that right now I have not written anything, but don't throw an error. So we can remove this pass. Now the first task is to go to beepers, which is one step forward. So using move, we go to beepers. We run the program, it goes. Then we pick 3 beepers, which is pick beeper, and then one more pick beeper. Again, let's do incremental testing. So we do reset the world, run the program again. So we see there are only 2 beepers left here, just to make it a little faster. Okay. Now go to target. Now there are different ways to go to target. You can either go up from here and then go right, or you can go forward and then turn. It doesn't matter. So let's do one move command to go forward, and then we have to turn left. Then we have to move one. Now let's run the program here. Okay, so we set the world, we run the program. Now at this point, Karel needs to turn right. So far we have not turned right. Karel only knows to turn left. So how do we turn right? So let's add a comment here, turn right. Okay. See, if Karel takes 3 left turns, it's equivalent to having a right turn. So we do turn left, turn left, turn left. Okay, let's try. Let's make it a little faster. Okay, so now Karel is facing east, so we are good there. Now Karel is still away from the target, so to achieve that, Karel needs to move twice. Karel needs to put 3 beepers there, so we put beeper. Okay, now let's quickly run the program again. Okay, so Karel is at target, put the 3 beepers. Now Karel needs to come back home. To return home, first Karel needs to turn around. Now here we took the function from the previous file, previous program. So let's call turn around. Sorry. So after turning around, let Karel move twice. Okay. Now again, Karel has multiple options, either to go all the way forward and then turn left there to go home, or it can turn left at this point and then move one more step. Let's reset and run. So now Karel is facing south here. Now Karel needs to turn right to face west. So let's add a comment here, turn right, and then we take these 3 turn lefts, add them here. After turning left, then Karel needs to move twice to go to the end. And finally, Karel needs to turn around to face east. So let's reset the program, run it again. Wonderful. So this completes our task. Now before we move forward, we always look for opportunities to reduce our code base and write functions to avoid repeating code. So here we have turn right used in multiple places. So we use turn right as a function and then replace the code with turn right function, which is over here and then over here. Okay, let's reset, run the program. It works. This is another problem to solve. You can find the solution along with the words file in GitHub. Today we have learned about Karel, setting up PyCharm and Karel, how to write a Python program, write commands, create functions, and decomposition. In part 2, we will learn about loops and conditional statements and how to use them effectively to interact with Karel. Thank you.